In this video, I am going to show you how to find the radius of convergence of a power series. So when we are looking for the radius of convergence, we need to determine what test we want to use to find whether the power series converges or diverges. And then if it does converge, find the radius of convergence. Well, as it turns out, the ratio test is an excellent test to use for finding convergence of a power series, especially those like this one that involves factorials and n's raised to the nth power. So I am going to use the ratio test. To use the ratio test, of course, we need to determine the value of a sub n plus 1. So in this case, that is going to be 2 times n plus 1. Now be careful, that whole thing is then having the factorial taken of it, times x to the n plus 1, all over n plus 1 raised to the 2 in parentheses n plus 1 power. So the placing of the parentheses in two spots where there's a 2n is very, very important. Make sure that you put that in parentheses. Well, the next step then is to take the limit. So we want to find the limit as n approaches infinity of the absolute value, and now I just have to rewrite all of this, 2 times n plus 1 to the factorial times x to the n plus 1 all over n plus 1 raised to the 2 times n plus 1. And now we would be dividing that by a sub n, but I am going to multiply it by the reciprocal of a sub n. And a sub n, of course, was what was written up here in red, is n to the 2n divided by, in parentheses, 2n factorial times x to the n. So that's what we need to do. The fun part is what we're going to be doing now, which is to break this apart and see what we can cancel out. So the limit as n approaches infinity, now 2n plus 1 factorial is, I'm going to do this in steps, so this is 2n plus 2 factorial. The x to the n plus 1, we've done that before. That could be rewritten as x to the n times x. The denominator would be written as n plus 1 all raised to the 2n plus 2 power. And then we have our a sub n, which right now I'm not doing anything to. So we can do a little bit more playing around algebraically with this. And so this would look like the limit as n approaches infinity. Now this is the fun part. The 2n plus 2 factorial. We've done this before where we factor out the largest number in the factorial. As an example, if we had 8 factorial, which is 8 times 7 times 6 times 5, etc., we could factor that as 8 times 7 factorial. So what we're going to do right now is we are going to do something similar to that so that we can have something to cancel out with this. So I'm going to factor out 2n plus 2, and then I could write 2n plus 1 factorial, but that's not going to help me. I'm going to take one more out of that, and then I'm going to be down to 2n factorial. So I'm taking out the two highest numbers, these two, and then writing the remainder as 2n factorial. And then we have n to the 2n, and don't forget the x to the n times x, all over in the denominator, n plus 1 to the 2n times n plus 1 squared times 2n factorial times x to the n. Now, what cancels out? Well, 2n factorials cancel out. X to the n cancels out. And that's about it. So with all of this stuff that's left over, we need to figure out how exactly we're going to take the limit of all of this. As it turns out, we have to do it piece by piece. And so we have the limit as n approaches infinity. And I'm going to break this into two parts. First of all, we have the 2n plus 2 times 2n plus 1. I'm going to put that all over the n plus 1 factorial. And I'm going to multiply that by the n to the 2n over the n plus 1 to the 2n and times the x. The reason I'm grouping them this way is because these terms all are raised to the 2n power, and these are all just polynomials. And then we have our x. Now the x we're going to remove. So in the next step, what I want to do, let's go dark green. I haven't used that. We're going to, now the limit of a product can also be rewritten according to our limit rules as the product of the limits. So first of all, let's bring out the x times the limit as n approaches infinity of the first term. Now multiplying these two terms together, we will end up with 4n squared plus 6n plus 2, and then multiplying this, or expanding that binomial, we have n squared. Oops, that's supposed to be an n up there. My bad. That should be an n squared plus 2n plus 1 times the limit as n approaches infinity of n to the 2n over n plus 1 to the 2n. Now we've done enough limits to know, and we have enough techniques that we've learned that you should be able to evaluate this. You can do L'Hopital's rule. You can divide everything through by the highest power of n, which is n squared. Any way you want to shake it out, this whole thing is going to become 4. So the limit of this rational function just becomes 4. So what I want to concentrate on is, what do we do with this? And so the limit of that, we have the limit as n approaches infinity. Now both of these are raised to the 2n power. So I'm going to group it as n over n plus 1 to the 2n power, which could also be rewritten as the limit as n approaches infinity of n over n plus 1 to the n, all raised to the second power. Now the reason I want to break that apart like that is because the part that is now n over n plus 1 raised to the nth power, let's go back to red, the limit as n approaches infinity of n over n plus 1 raised to the nth power, that is all the reciprocal of e. E is defined as n plus 1 over n to the n. So this is the reciprocal of e. And so that is then being raised to the second power. So in other words, this all becomes 1 over e squared. And consequently, we could then, putting all of this together, we have the absolute value of x, the absolute value of 4, and the absolute value of 1 over e squared, which becomes 4 over e squared x, and that has to be less than 1 to converge by the ratio test. So what we end up with then is the absolute value of x is less than e squared over 4. And so the radius of convergence is going to be e squared over 4. So this is an interesting problem. It tests your knowledge of the ratio test, of how to deal with all of these different factors and how to break them down. It throws in E. E comes up in a lot of problems in this class, so you should know the definition of E and be looking for it when you see it. All right, hopefully this was helpful.